This video is sponsored by Train World, America's discount model train store since 1968.
Hey everybody, it's Jimmy from the DIY and Digital, and today we're modifying the Arduino Multiblock signal system to use current sensing. Welcome back everybody. This video is sponsored by Train World. You can check them out at trainworld.com. They're America's discount model train store since 1968. They've got a wide selection of products, so check them out, trainworld.com. They're doing a lot of cool stuff like virtual train shows right now as well. I love following them on Instagram. So today we are taking the Arduino Multiblock signal system, which is one of my most popular tutorials, and we're actually going to make it a little bit simpler and a little bit easier to add to an existing model railroad. And how are we going to do that? We're going to be doing current sensing. Now in the previous Arduino tutorial, I showed you guys how to use a BD20 and using it with the basics of it. So today we're taking what we learned in that tutorial and applying it to the Arduino Multiblock signal system, and it actually makes the coding a little bit simpler. So let's go ahead and get started.
Before we begin, we'll go over the parts that we need for this tutorial. Those are an Arduino, preferably an Arduino UNO if you're doing the prototyping, a breadboard, some LEDs, 2 greens, 2 yellows, and 2 reds, a BD20 from NCE to do your current sensing, and some wires with some DuPont connectors. Here's the BD20. You'll notice it has a few things here that are very well labeled. We're going to be using the logic pin, the 5-volt pin, and the ground pin. The logic pin is going to be hooked into a digital pin, and the 5-volt and ground are going to be hooked into our power strip. The first thing we're going to do is install the LEDs on the breadboard, and you want to make sure that you're sharing a common anode or positive for this. Now there's a schematic for this in the description below. Next, we're going to go ahead and connect the 5-volt and ground to our power columns on our breadboard. Now we need to connect our LEDs to the Arduino. Green one will need to go to digital pin 2, yellow one will need to go to digital pin 3, red one will need to go to digital pin 4, green 2 will need to go to digital pin 5, yellow pin 2 will need to go to digital pin 6, and red 2 will need to go to digital pin 7. You'll also hook a 5-volt line from the power strip into the common anode of the LEDs. The next thing you want to do is take your bus line to the isolated rail that we're going to be using for current sensing and wrap it around the sensor section of the BD20. If you want some basics on how this works and everything, I've done a basics of current sensing video. Here is a link right up here as well as in the description below. You'll want to hook in the BD20's 5-volt and ground connections into the power strip on the breadboard. We're then going to connect the BD20 to pin number 10. So now we're going to hook up our send and receive pins for communicating in between the blocks. Remember, this system is designed to be expanded indefinitely, which is why I wired it this way. So first of all, digital pins 8 and 9 are going to be our block A and block B send pins. They are going to send the signal to the adjacent blocks. Block A is going to be the block that is preceding this one in the system, and block B is the next one in the system. Now, the receiving signals from these are going to be handled by analog pins A0 and A1. That means that A0 is going to receive a signal from the preceding block, or block A, and A1 is going to receive a signal from the next block, or block B. So what that means is you're going to have to take a wire from pin 8 and connect it to pin A1 of the preceding block. And you're going to have to take a wire from pin 9 and connect it to pin A0 of the next block. Another very important thing for this is you have to have a common ground that connects all of the Arduinos together in the multi-block signal system so that it will work. If you want a more detailed explanation of this, you can check out my infrared multi-block signal system where I go through the full explanation of how this system works. I'll link that right up here as well as in the description below. Okay, we have the entire thing put together, and now we're going to go ahead and hop into the Arduino IDE and do some coding. Okay everyone, we're in our Arduino IDE, and the first thing as always is we're going to declare our integers. So what we're going to do is do int sensor equals 10. And this means that sensor is set up on digital pin 10. I'm going to do int green 1 equals 2. And then we'll do yellow 1, 3. Red 1, 4. Green 2, 5. Yellow 2 on 6. Red 2 on 7. And what that basically does is it sets up all of our pins as the outputs for what we're going to call the green 1, 2, or green 1 and 2, yellow 2, and red 2. So let's continue on. So now, as before, we're going to have int block A send equals 8. We're going to have int block B send equals 9. And what that does is that sets up the signal to be sent to previous block, and this sets up signal to be sent to next block. Now we need to do int block A receive equals A0, and int block A or block B receive equals A1. And this sets up A0 as pin for receiving signal from previous block, and this sets up A1 as pin for receiving
signal from next block. And then the last thing we need to do is int clear count. All right, now we can start our void setup. So we're gonna do void setup. And we're gonna do our little parentheses and go ahead and do our bracket. First thing we're gonna do is start up our serial process so we can read what the sensors are saying. So we're gonna say serial.begin 9600. And that is the baud rate that we will be using. So now we're going to be establishing all of our pins as inputs or outputs right here. Pin mode, sensor, input. Pin mode, green 1, output. Pin mode, yellow 1, output. Pin mode, red 1, output. The vast majority of these are going to be outputs. Pin mode, green 2, output. Pin mode, yellow 2, output. And pin mode, red 2 is an output. Now we need to do pin mode, block A, send, it's an output. Pin mode, block B, send, is an output. Pin mode, block A, receive, is an input. And pin mode, block B, receive, is an input as well. And that is all of our initial setup right there. So the next thing we need to do is we need to enumerate our signal states. Now this is where the code gets simplified a lot because we're using current sensing and it can tell constantly that there is something on the track in the specified area that it is sensing current from. We will be able to do just one red state instead of the initial 3 or 4 depending on how you have to do this. So that's where this is going to get a lot simpler. So let's go ahead and start off with SD_GG, that's green green, that means both lights are green. SD_GY, 1 green, 1 yellow. SD_YG, which is the opposite. Then ST_YY, which is where both are yellow, and then ST_RR. We don't need to do a 1, 2, or 3 like we did with the previous multi-block signal, so we'll just do that. And then we're going to do ST_YY1, which is when it's coming out, it's going to be yellow for 5 seconds before going to green and checking again. And one little thing for formatting, I did forget to put brackets. It's usually helpful. So we'll go ahead and say what that is. So that is all the different signal states that we can switch to. Now we eliminated 2 of them simply by using current sensing. Now we need to establish the default one, so we'll say signal states, signal state equals st_gg. So that means that green is going to be the default. All right, now we can get into the fun part. So we're going to go ahead and do void loop, and then we're going to make some new integers. We're going to go integer value A1 equals digital read sensor. So we're going to be telling if the sensor is pretty much sending us 0 or a 1, and that's one of the good things about using the BD20 in this, is it's going to just send straight up 0 or 1, so we're able to hook it up to a digital pin. All right, A2 is going to be analog read block A receive. And value A3 is another analog read block B receive. So that's setting up to save our values for sensor, block A, and block B. We then need to do serial.println value A1. Little formatting error right there. Nope, there we go. And I'm just going to copy paste and change it to value A2 and value A3. And that sets up our serial monitor reading, which is this tool right here. And then we're going to go ahead and set up a delay of 200 milliseconds or 0.2 of a second. Now we need to establish our switch. So we're going to say switch signal state. Go ahead and put a bracket. We're going to do case st_gg colon, and that's going to be called signal GG. We're going to value A1, value A2, and value A3. And then we're going to use break. So then we're going to just, rather than retyping it each time, we're just going to copy it and paste and adjust. This is a big time saver. It's a YG. And we're going to do YY. Then we're going to have RR. Don't forget to change the letters in the signal as well. Then we're going to do YY1 and then YY1.
So what this is doing is this sets up our different sub loops within the main loop so that it can switch in between the different signal state. And now we can go into coding the first one, which is going to be very similar to what we've done with the multi-block signal. Remember, we're really just modifying this code. The original code is linked up at the top as well as in the description below. So we're going to do void signal GG int value A1 int value A2 int value A3 parenthesis bracket. First thing we need to do is digital write green 1 low. Now that seems counterintuitive. Remember, we're hooking the individual leads out of the signal into as their ground, so they have a common anode or positive, and they have separate ground. So low is actually going to be what does it versus what we've done in the past with high. So now we're gonna have to write one out for each signal. And the reason we're saying high is because of that, using the separate cathodes or ground rather than common ground and separate positive pins. And again, that turns that on. And then we also have to do digital write block A send low. And digital write block B send low. And that means that there's no signal coming out to tell the other blocks that this is occupied. Now, one of the different things that I'm doing for this, I'm adding a few things for the serial monitor. So I actually added a line where I said serial print ln, and I say no train. Just a little fun thing to say. That you know that there is no train. Rather than having to decipher numbers, you can see it says no train in the block when you're looking at the serial monitor. And then I do a delay of 0.2 of a second. And I also make this a reset point for the clear count, which will become important later. So now we need to go into our if-then statements. So now we can do if value A1 is greater than 0 because the logic signal sends out a 1 when nothing is in there. And what you do 2 ampersands for, value A2 is less than 1000, and value A3 is greater than 1000, and I see a little asterisk went in there. Now I do have to put these in parentheses. This will mean that the signal state changes. To SD_GY, so green yellow signal. We're going to say that this block is clear, but block B is occupied. And now we're just going to copy all of that. And then we're just going to flip-flop all the signs here. We're also going to switch it to YG, yellow-green. And that's basically that block A is occupied. Then we're going to paste again. And we're going to say if both of them are greater than 1000, this needs to be yellow, yellow. And blocks A and B are occupied. And then, last but not least, we need to do RR. And the great thing about this is we can just delete all of this out. And we see that it's less than 1. I'm not sure why it works differently for me, where if I say it equals 0, it glitches more often. But if I say it's less than 1 to represent it equaling 0, it works. So, you know, if it ain't broke, don't fix it. So, if the value is less than 1, aka equal to 0, then the signal state is going to go to red, and that means block occupied. So there is green, green. Now what we're going to do to save time here is we're actually just going to copy. Since you have to do very few changes, we're just going to copy and paste the blocks. So we're going to do green, yellow first. So we're going to take this, we're just going to swap out green 2 and yellow 2. And then I'll put a little note here. Turns yellow 2 on. And we're going to change that to approach with caution. And so now I need to, since this is GY, we need to change this to GG. And we need to say everything less than 1000. Now the reason I'm doing 1000 is because we're going to be sending a signal that's maxing it out, and the max number you can have on this is 1023. So to prevent any glitching, we're doing it up to, it has to be over 1000 to trigger the yellow signals.
So that's why this is all over 1000, and I haven't done that before. It's working a lot better than in the previous iterations, so that's why we're doing it this way. And then we're just saying block clear, and then everything else is the same. So there's GY. So now I can do YG. And then we just need to switch out green 1 and yellow 1. I'll put a note right here. To turn yellow 1 on. So now we need to go into here. And we need to go to YG and switch to GG. And swap that out to where both are below 1000, and then we just say block clear. So there's that, and now we have to do yellow yellow. So we'll do YY. And this one, we have to switch out both of the yellows, obviously, because we're turning them both on. So this turns yellow 1 on. And this turns yellow 2 on. And then we're just going to take this and go GG and flip-flop the greater than, less than signs. Now we need to do the RR. So we'll do this RR. And now we need to turn on both the reds. And there we go. Now we've turned on red 1 and red 2. Now we need to change up all of our if-then statements. So basically what we're going to do is we're going to delete all of that. And while we're at it, we actually don't need our clear counts in any of these. It's not going to hurt it if you leave it in there. It's just going to reset the clear count to 0 anytime it switches states. But we really only need it at the GG. The big thing with RR is we're doing a lot of different things with it. So the big thing we need to do first of all is we need to change our block ascends to high. And this means signal from block. And then we're going to change our text right here to block is occupied. So that's the basic changes. Obviously we're going to change it to where the red lights are on, and then we're also turning on the send signal so that it'll be sending a signal to the adjacent blocks, and our serial print line of block is occupied. So now we need to do our new if-then statement, which is really just going to be one of them because we just needed this to switch to YY1. So we're going to do if value A1 is greater than 0, we're going to do signal state equals YY1. And YY1 is just the signal state that comes out of red, so we don't need to do anything else. So this is YY1 is the one way out, so we don't have to do all the different if-then statements. So we're going to and this switches over to the transition yellow signal state, which is YY1. So now we need to do YY1. So I'm going to copy this again. I'm going to paste it, and then we do YY1. Now we turn on our yellow signals. Now the big thing I'm going to do here is I'm going to leave it transmitting. This is actually something I didn't do when I was originally designing it, but I'm going to leave it transmitting in YY1 because that means that the train is exiting the block. So it's going to be still transmitting that it's partially occupied. So first of all, so there is that. So now we can do what's going to send this over back into the normal cycle. So the first big thing we need to do is we need to switch this over to delay of 1000. And that's going to be checking every second versus every 0.2 of a second. So now we need to modify our code to say that if value A1 is greater than 0 and clear count is less than 5, this is just going to add the clear count. So what we're going to do is clear count plus plus. So that's just going to add 1 to it every second. So if it's less than 5, it's going to add a single digit to the clear count. So 1, 2, 3, 4, 5. Now we need to do else if value A1 is greater than 1 or less than 1 and clear count is less than 5. It's going to reset. So this is really just a simple way of checking to make sure we don't have any false positives. So let's say rather than something skipping over, it has to read 5 clear signals over 5 seconds to be able to designate that the block has been cleared. So this is just a little bit of a fail-safe to prevent false signals of clear track to come out if the train hasn't cleared it. And then last but not least, because this resets everything, if value A1 is greater than 0, I actually just noticed a formatting error, so there we go. And clear count is greater than 4. Signal state equals st_gg. And that'll send us back to restart the whole process once you've gone through all this. So it'll click over to green, and it may do it for just a half a second before it were to switch over to a green yellow or a yellow green or a yellow yellow. But that'll reset the whole process. So that is everything. I'm just going to put that is pretty much how this entire thing works. It's a slightly simpler version of the multi-block signal system. It'll still work like the multi-block signal system where you get to send to other signals, and it will integrate with the other multi-block signal system. So if you've already installed infrared sensors and you've already done that, you can add this to it. So it's not like you have to rip out all your sensors and do something else. You can leave that, and then this will just add on to it just by hooking it in. So wanted to make sure that it would do this because I know a lot of you have implemented this system. So let's go ahead and check this out.
So sometimes an errant space or character can completely ruin your code. If you run into this, I advise just copying lines of code from my working code that I have linked in the description below.
So basically what happened is some weird space or something, I've had this happen before, some weird space or something just threw this whole section off right here. I don't know what happened, but basically what I did was I isolated by copy pasting from a working version of the sketch, and I kept eliminating down until I figured out that this little section right here was the cause of all the problems. So what I did was I deleted it and then hand retyped it, and now it compiles and we are good to go. So we can go ahead and load it in. Okay, we've got our code loaded, so now it is time to test it out.
First off, we have the isolated rail right here on our test track. That is wired up with wire going through the current sensor. Now we're also going to be using this Arduino Mega right here with a few lines of basic code to simulate adjacent blocks. In a real usage of this, you're just going to have more blocks that are connecting to this. Now let's test it out. You can see the train running across triggers the signal. Now we'll simulate an occupied adjacent block. And last but not least, we'll make sure that it runs even when a locomotive is completely stopped on it. And there you go. There is the multi-block signal system complete with current sensing.
So that is the Arduino multi-block signal system modified to be able to use current sensing. It simplifies the code a great deal, and it makes it a lot easier to install on your model railroad if it's already an existing railroad. Now, if you have a DC layout, this will not work, but the infrared sensor version of this still does work. I'll link that right up here, as well as in the description below. Also, if you're wondering about just having a rolling stock on there, you can get resistor wheel sets, and I'll try to find some of those and link them in the description below, and those will help with a little bit of current draw that will allow the sensor to pick them up. So that's it for today, guys. Quick thing about the Etsy store, the fuel dealer and the freight depot last week sold out in less than 24 hours. So I've decided to do another quick run of them, another 4 of them. So those are on sale right now in my Etsy store. So go ahead and go check those out. And while you're at it, go ahead and hit that subscribe button, hit that like button, and hit that bell icon so that you don't miss any updates like this video. Special thank you to Train World, our sponsor for this video. And special thank you to all my patrons. They're listed right up here. If you want to become a patron, you can check out my Patreon page in the description below. Until next time, I'm Jimmy from the DIY and Digital. Happy railroading. Applies the code a great deal, and that is something that is always good. No, I put them in the thing.
I saw 4. Where's the other 4?
I only saw 4. We're looking for the kids' fish sticks, guys. Don't know where they are.
That is why there were, because I counted them. There were 8.
I hope she knows what's going on with blooper reel for this episode.